Hello everyone, this is Cameron from EDUCO, and in this video we're going to be looking at factoring using the quadratic formula. So we have a couple of learning goals for this video. The first one being we're going to define the quadratic formula and also understand when it can be applied to factor a polynomial. And then we're going to look at an example of factoring a polynomial using the quadratic formula. So first, to define what the quadratic formula is, it's a formula and it allows us to solve any quadratic polynomial in the form ax squared plus bx plus c equals 0. So a quadratic polynomial is a polynomial of degree or highest exponent equal to 2. Okay, so when the highest exponent is equal to 2 in a given polynomial, we call that polynomial quadratic. So the quadratic formula is given below right here. So x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So you notice that there's three variables in the quadratic formula, and those variables relate back to this standard form, ax squared plus bx plus c equals 0, where a is the coefficient in front of the x squared term, b is the coefficient in front of the linear term, okay, and c is the constant at the end. So we're going to look at the steps required to use the quadratic formula in order to factor a polynomial. So the first step that we need to do is write the quadratic polynomial in standard form. So what do we call standard form? Well, the standard form is this ax squared plus bx plus c form, okay? So we write the exponent, the terms with the exponents in descending order, okay? So the x squared term comes up first, then the linear term, and then the constant at the end. Because a constant is really just, you can rewrite that as x to the 0, right? So it really has an exponent of 0, okay? Anything to the power of 0 is equal to 1. And then we're going to identify the values of a, b, and c. Okay, so once we write the polynomial in this standard form, we can identify and read off the values of a, b, and c directly from that polynomial. And then, once we have those values, we can substitute them into the quadratic formula and solve for x. More specifically, when we do that, we're solving for these values of x1 and x2 down here in the last step. So once we solve for the values of x, we'll get two values, and then we substitute them into the factored form, which is a, so that's the leading coefficient. So the coefficient in front of x squared, that can also be called the leading coefficient sometimes. So it's a times x minus x1 times x minus x2, where x1 and x2 are the roots of the quadratic formula. Okay, so when you solve for the quadratic formula, you get two values of x. Those values of x represent x1 and x2. Now, the ordering actually doesn't matter, okay? Which one you label x1, which one you label x2, doesn't matter. You will get the same answer regardless. So now let's take a look at an example where we're going to factor the following polynomial. Minus 5x plus 2x squared subtract 12. So the first step, remember, is to write the polynomial in the standard form ax squared plus bx plus c. So the quadratic term must come first, then the linear term, and then the constant. So as you can see, the terms are a little bit rearranged in this polynomial, so we got to first write them in descending order. So the quadratic term comes first, so the 2x squared. Then the linear term comes next, so the minus 5x. And the constant at the end, which is minus 12. So now let's recall what the quadratic formula is. So x equals minus b plus or minus square root b squared minus 4ac divided by 2a. So before we start plugging in values into the quadratic formula, we got to identify the values of a, b, and c. So that's the next step. So my a value is the coefficient in front of the x squared term. So in this case, that's equal to 2. My b value is the coefficient in front of the linear term, okay, or in front of x. So that's -5 in this case. And then c is the constant. So it's at the constant at the end. So that's -12. So now I can start plugging these values of a, b, and c into the quadratic formula. So x equals a minus b, so that's going to be a negative of a -5, plus or minus the square root of b squared, so that's a -5 squared, subtract 4 times a, which is 2, times c, which is a -12, and that's all under the square root. And then this whole thing is divided by 2 times a, so a is equal to 2. 2 times 2 gives me 4. So now this is equal to, so these two negatives will cancel. I'll be left with a +5, plus or minus the square root. -5 squared gives me 25. Again, these two negatives will cancel and give me a plus. 4 times 2 is 8. 8 times 12, that will give me 96. And that's all divided by 4. And that's equal to 5 plus or minus the square root. Now 25 plus 96, that will give me 121 divided by 4. And the square root of 121 is 11, so that's 5 plus or minus 11 over 4. So I got two values of x, so I'm going to say that x1 equals 5 plus 11 over 4. So 5 plus 11 over 4. So that's 16 over 4, okay, which is 16 over 4, which is 4. And then x2 is 5 subtract 11 divided by 4, which is a -6 over 4. And if I reduce this fraction, I'm going to divide top and bottom by 2. So that'll give me a -3 over 2. So now what we can do is we can perform the last step, which is to substitute the values of x1 and x2 into the fully factored form. So remember, the fully factored form is a times x minus x1 times x minus x2, okay? So again, the labeling of x1 and x2 doesn't matter, okay? It doesn't matter the order in which you label them. So a is equal to 2 times x minus x1. Well, x1 is equal to 4 times x minus x2. So that's x subtract a -3 over 2. So this is equal to 2 times x minus 4. These two negatives will cancel, and that will be x plus 3 over 2. And I'm going to do one small algebraic step to simplify this answer a little bit more. I'm going to distribute this 2 into the second bracket, because I notice in the second bracket that I have a fraction. Okay, so to make this a little bit more neat, what I can do is I can distribute that 2 into both terms inside of that second bracket. So the x minus 4 stays the same. And then 2 times x gives me 2x, and 2 times 3 over 2, well, that will just give me 3, because these 2's will cancel here. So my fully factored form is x minus 4 times 2x plus 3. So in this video, we looked at the quadratic formula, so we defined that formula. We now understand when it can be applied. It can be applied to any polynomial of this standard form, ax squared plus bxc plus c equals 0. And we learned how to factor polynomials using this quadratic formula.